Hi, the SI meteorologist Paul Dorian here with a brief discussion on El Nino and La Nina. These are terms that we've heard often over the last several years, especially El Nino. We want to talk a little bit about what they are and why they're important and how these sea surface temperatures are measured. First of all, El Nino refers to warmer than normal water temperatures in the central part of the Pacific, the tropical part of the Pacific near the equator off the western coast of South America. La Nina refers to a condition where water temperatures are colder than normal. In fact, we're experiencing a La Nina right now in the central Pacific that is actually fading away and becoming more of a neutral signal. By the middle part of the summer here in 2011, I expect a rather neutral signal, neither El Nino or La Nina, by the middle part of the summer. The satellite system that is used to monitor the sea surface temperature in the Pacific is a polar orbiter that has an instrument on board called the AVHRR. That stands for Advanced Very High Resolution Radiometer. It circles the globe maybe 14 times a day and monitors the sea surface temperature, and we get a weekly output, a weekly update on the sea surface temperature. Let's take a look now in the recent history for an example of an El Nino and a strong La Nina. Well, here's a global map using the AVHRR data to come up with sea surface temperature anomalies. This happens to be in the year 1998, and there was a very strong El Nino, or warmer than normal condition, in the central Pacific off the west coast of South America. Here is South America, and all these oranges and yellows and reds represent warmer than normal temperature, sea surface temperatures here in the central Pacific. This was one of the strongest El Ninos ever recorded and had an impact on global temperatures, for example, that soared in the subsequent 6 months to 12 months after this particular El Nino event. Now, one of the reasons why El Nino is very important to monitor is the fact that this is the Pacific Ocean, and it's the largest ocean on Earth. In fact, the other 4 oceans combined will not fill up the entire Pacific Ocean. So what happens in the Pacific has a major impact not only in the Pacific region itself, but on the U.S. and the rest of the world. And in fact, El Nino, such as this particular situation, actually has an impact on tropical Atlantic season. It's been determined by some studies by researchers that when there's a strong El Nino situation, as was the case in 1998, early part of 1998, upper level winds actually increase in the central part of the Atlantic, the tropical part of the Atlantic, and these upper level winds tend to inhibit the tropical storm development in the Atlantic. So what's going on in the Pacific can have a direct impact on the tropical Atlantic season. Additionally, of course, the temperatures in the Pacific Ocean have an impact on the tropical activity that's going on in the Pacific. The last couple of years, for example, we've had a La Nina state, colder than normal temperatures in the Pacific, and a much reduced tropical activity in the Pacific Ocean because of that. Here is an example of a La Nina situation with colder than normal temperatures just 2 years after that strong El Nino. This is early part of the year 2000. Again, we're South American coast, and in this case, lots of blues, dark blues, light blues, representing colder than normal temperatures, and this was a pretty strong La Nina signal. So again, these are monitored on a weekly basis by this particular satellite system, and La Nina or El Nino conditions are very important not only for the Pacific region but for the rest of the world. One of the nice ways to monitor this situation is by what NOAA does. They put together an index that represents El Nino or La Nina conditions. This index goes back several years, and the reds represent above normal or El Nino conditions, and the blues colder than normal or La Nina conditions. A couple of maps we just saw recently represented right here the La Nina condition in the year 2000, for example, with all these negatives, and just 2 years before that, the strong El Nino that started in 1997 and continued into the early part of 1998. Now notice there's a lot of bouncing back and forth between El Ninos and La Ninas. These are rather short-term cycles that occur in the Pacific Ocean, and there's many theories out there as to exactly what causes the changes. There's still some unpredictableness in terms of the La Nina and El Nino. it's very hard. For example, there are some models that go out several months and try to give a forecast, but right now there's really no certainty for a forecaster to say what may be the case a year from now or 2 years from now. Strong El Nino or strong La Nina or somewhere in the middle. We're advancing. There are some models, again, that go out several months, and that will continue to improve undoubtedly over the next several years. A couple of theories as to the cause. Well, solar cycles may play a role in these particular ocean temperature cycles. Underwater volcanic activity also may play a role. It's just not exactly totally known yet, so therefore it's not totally predictable, but we are making advances. And again, even though there's still some unknowns, what is known is that what goes on in the Pacific is very important in terms of global weather and climate, and so we'll continue to monitor the situation periodically here on the siweather.com, and this will undoubtedly be a topic of conversation over the next several years. That's it for now. I'm the SI meteorologist, Paul Dorian.